Hello, welcome to Oniro-with-zyga. I will show you how to use the HawkBit dashboard to update a running Linux-based system. To follow along, you will need a HawkBit instance with an uploaded bundle and a virtual machine with the Oniro-based image running. As always, you can get those by following my earlier videos. Let's review what we have prepared so far in this series. In our terminal, we are using the runqemu command to boot a system built from the Oniro image base recipe. Inside HawkBit, we have a QEMU base distribution, module, and a bundle uploaded as an artifact of the module. We also have the QEMU x86 64-1 target that represents the running virtual machine. To observe the process better, let's start by following the system journal. Switch to the terminal where you have the running virtual machine, log in as root, and run this command. This will allow us to come back later, scroll back, and check what was happening. Let's switch back to HawkBit. There are several ways to use the dashboard to perform an update, but on a small scale, the easiest one is to assign a distribution to a target explicitly. Click on the Deployment Management icon on the left. To begin the assignment, drag the Oniro base distribution on the right to the QEMU x86 64-1 target on the left. Now, there are several options here that we will explore another time. For now, the defaults are good. Click OK to continue. We can now watch the update unfold in front of us. HawkBit offers two APIs for communicating with devices, the push-based DMF API and the pull-based DDI API. Right now, we're using the pull-based DDI API. This means that there's a delay of a few minutes before the device detected the update and had started the process. I've cut this part out of the video. Let's review what had happened once the update was detected. Note that the device found an update to apply, downloaded it to a temporary location, verified the security signatures, found the slot to write to, and configured the bootloader for the update transaction. And finally, has reported back to HawkBit. Back in HawkBit, we can see that the update was successfully installed. The device has rebooted automatically after 3 minutes. During the boot process, the bootloader has performed a one-time boot of the new slots. In the future, we will see how the system can be used to automatically roll back to the previous version if a health check fails or a critical service does not start correctly. This mechanism can prevent bugs that were not detected during the QA process to persist in the field where they could be costly to address. You can now use the HawkBit dashboard to update Linux-based Oniro reference devices. The process we have followed was done with a virtual machine, but the exact same steps apply to all physical devices as well. Join me in the next video where I will apply updates to the Seco B68 board, also known as Alvin. Thanks for watching and see you soon.